In this video, we are going to discuss calculating linear regression equations using the TI-84 calculator. The table provided shows a teacher's analysis of several students, how many hours they studied, and their resulting test score. Our first set of instruction tells us to enter our data in our calculator. I already have my list screen up, but just so everyone is aware, to enter the list screen, you'll go ahead and click the Stat button and see where it says Edit. You just want to click Enter on Edit. So you can see my key history in the bottom. I hit Stat and then Enter to get here. I'm going to enter my X values, which are hours studied, in L1, and then my Y values, which are test scores, into my L2. So for L1, I'm going to go ahead and click 2.0, and after each one, I have to click Enter. Next, I'm going to have 3.5, Enter, 4.0, and just fill in that whole table with all your values. Okay, that is L1, which covers all of my X values, and then I'm going to jump over to L2. So L2 is going to be my test scores, same process, 65, and then Enter. Now that I have my L1 and L2 inputted, I can have my calculator create a scatter plot for me. So the first thing I have to do is make sure that stat plot is turned on. And that's logical. We entered our values in the stat menu on our calculator, so it makes sense we want the stat plot to be on. You might see this button that says Y equals that I just highlighted. Right above it is blue words that say stat plot, meaning you need to hit the blue second button before you hit the Y equals to get to the stat plot menu. You'll see plot 1 right now is turned off. I need my plot 1 turned on. So to do that, I'm going to click Enter and it'll hover over on. If I click Enter again, it will be on. The very first option here is a scatter plot. So you have several options there. We want a scatter plot, so it's already set to that. Our X value we entered in list 1 as the instructions told us to. Our Y value we entered in list 2. If you'd like to change the appearance of how those points show up, you can use that. I always just leave mine as squares. Now, to get to your graph to appear, you are going to click the zoom button in the middle of your screen, and you can either scroll all the way down to number 9 and click Enter, or you can just select number 9. It will spit out a scatter plot for you, and our instructions tell us to make a rough sketch. So that's what we're going to do. Underneath number 2, I'm going to make an X and an Y axis, and I'm going to kind of roughly estimate what this line looks like to me. Something like that. It models pretty closely to a linear line. So I think we're going to have to do a linear regression equation. Before I move on, I am going to label my x-axis as hours because we have hours studied as our x value, and then our y-axis as my test score because that is my y value. We're going to calculate the regression equation and store it in Y1. So remember, we already have our lists entered in the calculator, and they're just going to stay there even if we change screens. While they're in there, we can go ahead and calculate the regression equation. To calculate the regression equation, you'll go back to that stat screen, go over one to where it says calc. We're calculating all the way down to number 4, our linear regression equation. Click enter on that. X values were list 1. Yes, I agree. Y values were list 2. I agree. Now, if we want to store this equation, I put the instructions that we're going to store it in Y1. We're going to use this store regression equation feature. So to store it, we're going to go to vars, over 1 to y vars, click enter on the function, and enter on Y1. That will put our equation into Y1. Last step, we're going to go ahead and calculate this. When we click enter, it will calculate a linear regression equation for us. And remember, it did store it in Y1 because we did that linear regression storage feature. Our equation is labeled as y equals ax plus b. The a value is 3.5745, etc. And then our b value is 58.3167. And I'm going to go ahead and round to 3 decimal places and write out my equation. I'm going to say y equals, our a value is 3.575 x, and then plus my b value, which is 58.317. And your calculator says right at the top the instructions for how to write that out, and then it gives you your a and b value, just in case you forget. Next, it asks us what our correlation coefficient and our coefficient of determination is. Some people will have this already programmed in their calculator to show up as soon as you calculate your regression equation. I don't right now, so I'm going to show you how you get it to show up. To do this, you're going to go to the catalog menu. You'll notice it says catalog right above the button that says 0, but it says it in blue, so obviously hit the blue button, go to catalog, and then I'm just going to hold this down button. Hold it down a bunch because I want it to go all the way down to diagnostics on. I want my diagnostics to be on. Keep in mind, this is in alphabetical order, so you can just press and hold until you see it. I'm going to click enter on diagnostics on and enter one more time. Now my diagnostics have been turned on. So what this is going to do, when I go back to my stat and calculate menu and I go to my linear regression equation, I'm going to go ahead and store it again in my Y1. When I calculate it now, it's going to pop out with the R value and the R squared value. So I don't even have to do anything. My calculator gives it to me just like that. My R value is the one on the very bottom. My R is going to be 0.992. I'm going to round it to 0.992. So R equals 0.992. And R, our correlation coefficient, all it does is demonstrate how strong the linear relationship is. So that is what that is. If it was a perfect linear relationship, it would be 1. For the coefficient of determination, which is our R squared, it is going to be 0.984. The coefficient of determination, or R squared, just demonstrates how well the linear model fits the data. So this model that we came up with, it just shows how well it fits the data. If it's a 1, it fits the data perfectly. And I'm going to go back to number 4 and spell the word demonstrates right. Sorry, not demonstrates. Excuse me. Let's fix that. Demonstrates. Excuse me. All right. So we're going to interpret the point 6.583. We no longer need the calculator for something like that. Interpret just means to explain what it is, to give it meaning, to put it into words. So right now, what I am seeing is that this 6.5 is my x value. And if I go back up to my table, my x values are hours studied. So I know I have 6.5 hours studied. Now my y value is 83, and 83 is my test score. So if I put all of this together into a sentence, if this student or a student studied 6.5 hours, their predicted score on the test would be 83%. That's what I'm going to write down. that up a little bit. Sorry. There we go. Okay. My next question, number 7, asked me to predict the test score for a student who studied 7.5 hours. So 7.5 hours is going to be my X value, right? Because hours, if we look back at our table, is our X. So I have my equation right up here, and all I have to do is plug in 7.5 for my X in that equation. So this is what I'll do. I'll say y equals 3.575x times 7.5 plus 58.317. And I'm just going to go ahead and solve it using my calculator. So to use my calculator, I have 3.575 times 7.5. And then once I get that number, I can add 58.317 to it. And my total value for y is going to be an 85.1295%. So I'm going to say I estimate that student to get approximately 85%. Now, there is one other option here. Remember how we stored our equation in y1? If we go to the y equals screen, our equation is right there in y1. So if I wanted to see maybe a table, I could actually use my calculator to estimate this too. So I'm going to look at table, which is that blue button right above graph. So I'll hit second graph. And then it wants me to estimate 7.5 hours. Well, that would be right in between the 7 and 8. 7 looks like it's about 83%. 8 looks like it's about 86%. So I think our guess, our estimate or prediction of 85% matches the model, and it seems pretty reasonable. Keep in mind our rounding is a little different here because we rounded to 3 decimal places and our equation in here has like a million. All right, our last question here is, if a student scored a 75 on the test, how long do you estimate they studied based on this model? So a 75 is the score, and remember our scores are our y values. So we're going to plug in 75 for y into that original equation. I'm going to say 75 equals 3.575x plus 58.317. So to get x by itself, because that's what we're solving for, I can subtract 58.317, so minus 58.317. And I'll go back to my original screen. I'll say 75 minus 58.317. And I'll get 16.683 equals 3.575x. And of course, that cancels. Next, I can divide by 3.575. Again, I'm just trying to get x by itself. And if I divide that, my 16.683 divided by 3.575, I will get 4.666 hours equals x. I'm going to say this student studied for about 4.7 hours. Okay, that is finding your linear regression equation using your TI-84 calculator. Thank you so much.